This week, I will be introducing phases of the moon to the students. And ideally, I think it would be nice at some point to coordinate what's being done in the lab in the classroom and to have the students participate in a long-term investigation of the moon, where they look and notice where the moon is each day and perhaps draw what they see. And they could see that the moon changes phases throughout the month. You may have noticed that full moons rise in the east, and you view them right as the sun, is setting. So the sun sets, and there's that beautiful full moon. Or you may have noticed a crescent moon in the evening, and that moon would be located in the west, and it will set soon after sunset. So we're going to be looking at a model that will help explain the phases of the moon, and actually when during the day we see the moon. And so in this model, there's a flashlight, and the sun is very big, so we're going to just have to move the flashlight. But in this model, when the moon is here and we're on Earth, this is the daytime on Earth, this is nighttime, we really don't see that new moon. As the moon starts orbiting the Earth, right here we're at the first quarter, and I'm not sure if I can get that to show, but now you can see that the moon appears half lit. This is the quarter moon. And then over here we'd have the full moon, and then over here, we'd have 3/4. And in this phase right here, this is what we call a waxing gibbous. Waxing meaning that it's, getting larger, as if you're dipping a candle and every time you dip it, it gets more wax on it. Well, the moon becomes larger and larger and larger until it's a full moon. And then it's a waning gibbous. It starts to become smaller and smaller and smaller until it's, appears to be half illuminated. And then we say that it's a waning crescent, and then it becomes a new moon. So we have a waxing crescent, we have a waxing gibbous, we have a waning gibbous, and we have a waning crescent. And so students will look at this, and they'll be looking at how the shadow falls on the moon and Earth, and where is nighttime and that sort of thing. And then also we can really figure out what time of day the moon rises and sets, because if this is nighttime right here, on this backside here, then as the Earth turns, we'll come into night, and just as we come into night, we see the moon, and it's a full moon right at sunset, and we can see the terminator line right here. So just as we enter the darkness, we see the full moon. Now, today, the moon is right here, and so when we come into the light, into the morning, I can see the moon to the west. And so we notice that, so in the morning, I can see this beautiful waning gibbous moon today. So we're going to be working through this model this week, and then next week we're going to be using a variety of moon models, and the kids will be going through stations, and I'll talk about that later. So we'll use things like styrofoam balls and lights to talk about the moon. We'll also talk about sort of the size and scale of our solar system. So if this is the moon, this little round sphere right here, if that's the moon, the Earth would be about the size of a tennis ball, but they would be, about 6 feet away. So this model here is clearly not very accurate, but we'll talk a little bit about some of the problems with models, because every model has issues. It's not the real thing, and I think that's really important to talk to children about. So in this model, we're going to learn about, and this week we're going to be learning about the phases of the moon. We're going to be noting when the moon rises and sets using this turning Earth going into the shadow and into night and day. For example, here we'll have a full moon, and at midnight, it'll be straight up in the sky. Whereas, over here at midnight, it's going to be off to an angle. So it should be a fun week in the lab. I'm a little nervous about this lesson because it's pretty ambitious, but I think the kids are up for it, and I am.